If you've ever deployed a virtual network in Azure or anywhere else, you know how things can get messy quickly. One overlapping IP range here and one forgotten subnet there, and all of a sudden you have two environments that cannot talk to each other. Or even worse, things that used to be functional now isn't anymore because of a configuration error. So we as network engineers and cloud engineers, we have a responsibility when it comes to planning the network in a platform. And traditionally we've tracked IP ranges and other things with spreadsheets or dedicated IPAM systems, or sometimes just pure luck. But now Azure has entered the IPAM game, and that's actually a good thing for us. So in this video I'll show you how you can manage your IP address space, you can do your planning, and you can also plan for things that will not be in Azure, things that will be in on-premise or other clouds, but you can have the central management of it all in Azure. And we're going to do everything with Terraform, of course. So again, like whether you're a cloud engineer or a network architect or both, then this video is hopefully for you. Before we start, maybe we should start at what even is IPAM. So IPAM stands for IP Address Management, and it's a system we use, or a way we use, in order to track and document our IP ranges. So let's say, for example, you have a data center in a specific region, and that has a /16, which is a network with somewhat about 65,000 IP addresses. You will not have one big network that is 65,000 IP addresses. You will most likely be having slices of that big network and using it in terms of subnetting, and using it in virtual networks and subnetting in Azure, for example. So perhaps you have a front-end network where you have things that you are exposing to the internet, and then you have other networks which are usually referred to as backends, which will host your databases, application servers, things that aren't necessarily exposed to the internet. So when you have all of these different networks and they serve different purposes, then you need some way to document them, and that's usually where IPAM comes in. And the goal is to track what ranges you're using for what, so that you will not have a database subnet over here, and then in a different region or somewhere else you're going to have another subnet for another application, and all of a sudden, because you didn't track it, they have the same IP range, the same private IP range, and that means that in the end they can't communicate and they can't talk to each other. You would have to do some complex NUT, I guess, in order to get that to work, but you shouldn't be in a position where you have to do that, basically, is what I'm saying. So what we see here is going to be the high overview of what we're going to deploy. So first of all, we're going to need some resource groups to host everything. Then we want to set up our IPAM pools. So we're going to do 3 different environments today. So we'll have a dev, ACK, and prod deployment. We're going to deploy the virtual networks, and we're going to assign IP ranges from these IPAM pools. And then we're going to have a look at it all using Azure Virtual Network Manager, which is the underlying resource for all of this. So yeah, basically that's it. The plan is to show you how Azure Virtual Network Manager and the subsystem of that, which is IPAM, how it works in the Azure portal. And I want to show you how we're going to deploy with Terraform, and also show you an example of what if we have a network that we want to track in Azure, but it's not in Azure. Maybe it's on-prem, for example. So we're going to do an example for that as well. So we start in Visual Studio Code. I have done some boilerplating. I've added 3 variables which I will be using. One is environment, one is location, and one is location short. And also have a tfvars file where I've supplied the information for those variables. So the very first things, as per usual, we do need a Terraform block. And here we say we have a required provider, which is going to be AC API in this case. And we are working with the version 2.4.0. And then we also need to have a provider block for AC API, which we can add right there. And then I want to do something. I mentioned I will have 3 environments for this, and we're actually gonna build the locals first. And I want to call this IPAM pool environment config. This is going to be a map of objects, so we're going to have first a dev environment. And for the dev environment, I want to give it a display name. We can call it IPAM dev for the dev environment, SC, which is location short for Sweden Central, and yeah, we can call it pool, it's fine. Then we're going to want to have a address range, and this one actually needs to be a list of strings if I remember correctly, and it can be 10.000/18, and then we can actually just copy this, and this one is going to be AC, and this is going to have a range of, I believe it's 64 is the next one, and then we have production, which is I believe the next one from here is 128. So then we want to create a resource group per environment, and we do this by specifying a AC API resource. We will just call it RG, and we want to loop then through each iteration of IPAM pool environment config. We want to say the type is a resource group, and we want to say that the name is RG. Each key, which in this case, each key is dev, ac, and prod, which is fine. So we'll need the $sign here, not there, we need it there. Each key location short, which is SC, which is fine, and we'll call this core IPAM. Location, we can do var location. So this means that this should create 3 different resource groups. So if we bring up the terminal here, we can do a Terraform init to initialize this, and we can run a Terraform plan, and we'll say we want to use the variable file that I created. And we have 3 resources to add. I can see it's a resource group, production, then we have another resource group but for dev, and then we have the third one for AC, which is nice. So let's run an apply, and we can throw on an auto approve. Alright, so those were created fairly quickly. If we go into the portal and search for core IPAM, we have 3 different resource groups then. So usually you would probably have a dedicated subscription for an environment, but we are working with 1 subscription right here in this demo, and we're gonna separate on the resource group level. I actually do want to have yet another resource group actually, which is gonna be called shared services, and that is because we will have a different resource group that's gonna act as our shared service resource group, where the network manager is going to be stored in. It's also where the IPAM pools are going to be stored. So they are a service that all the environments use, but they are not tied to a specific environment. So we're going to put it in a separate resource group, and I can just accept that off rip. Location is fine like that. So if we run another plan, we get that we want to create another resource group. So let's do that. And if we're back in the portal, we can type shared service, and then, oh, I did see it, then it went away. Oh, there it is. So the next step here is that I mentioned that IPAM is a subservice of Network Manager, so we do actually need to deploy a Network Manager instance. So let's do that next. And like we usually do, we say we want a new resource. We can call this one Network Manager. The type is a network manager. The name we can accept. I want to have virtual network manager, and then we have our string interpolation. We can call it core. Location is fine like this. We could also do AC API resource group shared services location. So then we need to have the body here then, and we do get some help with this resource. So we have some required properties, and we have to tell it which scope that this network manager is going to manage under. So we're going to pick subscription, and here you can see that we need to supply subscription, and we need to give it the subscription resource ID. And what I usually do is I copy the subscription ID. We can actually create a new local, which I will call subscription resource ID. and it's going to be subscriptions and then the ID. So if we need to use this in several places, we can now just input our local here, which is nice. And this one usually complains unless we say that the schema validation enable should be set to false. And so let's see if we can deploy this. So again, we'll run a plan. We are missing a parent ID for our network manager. I thought something was missing. The parent ID for this one should be the shared services resource group. I'm going to put the resource ID of that one there. Let's run another plan. And here we are then. So then a network manager wants to be created. Let's apply. So the deployment was successful. So if we go to our resource group and we entered shared services, we can see now that we have a fresh network manager. And it's under here then, if we expand here, we can see IP address management has, or IPAM has its own little entry, and then we have our IP address pools, which we don't have any yet, but we're gonna create those next. And so here then we want one pool for each environment. So we're gonna have to work with our local again and do a little bit of a loop, but we can call these IPAM pools, and for each local IPAM pool environment config, we want to do stuff. First of all, we want to say it's an IPAM pool. So we'll say it's a network manager IPAM pools. We'll put the ID there. And for the name then, we want to do, if you remember, sometimes Copilot is not a friend. It confused me a bit. If you remember, we do have a value here which we called display name, and that's the straight up value that I want to use for this. So I can just say each value display name. The parent ID is most likely going to be the network manager, so we're going to put this here. And then we have to say a location. So let's do the var location again. And then we need to supply a body for this. Properties, and then we have some required properties for IPAM pool, the address prefix, for example. And I do think it's an object. Okay, it's not an object. Oh yeah, that's what I remembered. So when I entered address prefixes here, it wants to help me. So it's supplying the open brackets or the square brackets, because it wants to denote it as a list. But if you remember, we already made this a list. So the only thing we have to do is do each value address range, and we want to have a display name as well. So same thing here, each value display name. And this one usually also wants to have schema validation enabled false. So let's run a plan here then and see what happens. So we can see it wants to create 3 resources, which is hopeful. Then it's an IPAM pool for prod, and we can see that's the prod range, and it also picked up the name correctly. Same thing if we look into the dev one. So we have a dev IPAM pool, and we also have an acceptance IPAM pool. I like what I see, so I'm just gonna run apply for this, and it's created. So if we do a refresh here in our network manager, here we have 3 different pools. Now we have the pool, now we have our network manager, but now the whole point of us is to create the network, right? So let's do that next. And like we usually do, so we specify a new AC API resource. We just call it a VNet. Also then for this one, we want to loop for this one. So for each local IPAM pool environment config, we are trying to create a virtual network. The name here then, if we do it like it's suggesting here, it's going to be VNet each key, which again is dev, ac, and prod. So VNet, prod, for example, location short, SC, which is fine, core, which is also good. We don't need to call the VNet IPAM, it can just be core. The location is yet again just var location. The parent ID, so this is a little bit interesting. We want to create 3 virtual networks, and we don't want to put them all in the same resource group. They should go in their respective resource group that is created for their environment, basically. And it's pretty easy. We can do that by saying that we want to target our resource group. And oh yeah, it did it for us. So each key is functional here as well. So it knows that in this map here, it's gonna target each key, which again will be one of the environments. And we can see this actually if we run a Terraform state list. You can see we have resource groups, and they are called. So each key here is being translated correctly. Right, but then we do need to supply a body. And what is so nice about the IPAM feature in Azure is that usually you would supply an address space, and then you would use an address prefix, and then you manually entered like your address prefix. But then this needs to be tracked somehow, and then that would be most likely a third-party system or something. But now actually we can, instead of using address prefix, we can use IPAM pool prefix allocation. And this one is if we create an object, we can see a number of IP addresses. So I don't have to choose a specific range. I can choose to decide I want 1024 addresses, which equates to a /22 network. And I want to grab those next available addresses from the pool that I created. And we can do the same thing here, so that each key is going to work for us here as well. And then it's going to look in the IPAM pool, it's going to see how large is this pool, what ranges are available, and depending on your request, what is the next range that I can give you. So this is awesome stuff. So if we format that and also set schema validation enable to false, then we have our virtual network, hopefully or 3 virtual networks, hopefully. But we also want to have a subnet, right? So we can do pretty much the same thing. So we're just going to declare a new resource, call it subnet for each local again. Then this is the type subnet. The name, we can make it easy here. We can just say default. It's not a big deal. It doesn't need a location, but the parent ID is each virtual network again. So we can do each key ID. And similarly, as we did with the virtual network, we do have the address prefix within the body. Or sorry, not the address prefix. We can do straight away IPAM prefix allocation. Open another object, number of IP addresses. Here we want to /24, so we're going to grab that many addresses, and the pool is the same. So we supply the same pool here, and it's going to understand to pick from the correct pool, but it also understands, because of the parent ID property, that this is a subnet that belongs to this respective virtual network. So if we run a plan, again with these schema validation enabled, we should hope to see 3 resources being created. 3 virtual networks, 6 resources of course, 3 virtual networks and 3 subnets. And it looks like it, so we have our virtual network for prod, dev, and doc, and then we have a subnet for prod, dev, and doc. So if we clear that and run apply. So that was deployed successfully. If we go back to our core IPAM resource groups and we go into dev, we can see we have a virtual network and it's called dev, which tracks. If we go into this, we can see we have a subnet called default, which tracks. And here you can see it's referencing an IPAM pool, and it's also referencing this IPAM pool from the virtual network. If we click into this is awesome. We can see, so now we are in the IPAM pool for dev, for example, and then we do allocations. And then we can see, we were going to get some statistics, but we can see that we have a pool address space that is a /18. And we have 6% IP allocation and IP usage, none right now because we don't have any deployed resources, but we can see that both this virtual network and the subnet was created with the correct pool, and you can see here the subnet is a child resource of the correct network. And just for shits and giggles, we can go into prod and do the same thing. We have our prod virtual network. We go into the same IPAM pool, and then we can have a look at the virtual network here as well, which is awesome. So finally, I did mention that we had a way also that we are able to reserve addresses which are not in Azure. And there's actually a resource that is called static CIDR reservation. And so if we make a new resource, call it CIDR reservation, we can say, if we just search for, here we go, IPAM pool and then static CIDRs, we can call it that, that's fine. We can say the parent ID is the network manager, the location, that's fine, just to save on a little bit of time here. The body and properties, so then we have an address prefix here we can supply. And if we set this one to, I don't know, let's say we have 172.18.24, I don't know, I'm just making things up. Number of IP addresses to allocate, let's say we're going to grab all of them for this sake. The display name, does it have a display name? Sometimes there's some hallucination here. Description, so we could say this is an AWS network, or we could say this is an on-premise network, for example, just to keep track of it and make sure we don't overwrite this in Azure. So if you run a plan, again, always with the schema, we can see it wants to add the CIDR reservation here, so that looks good. We'll run an apply. Oh, I actually did a mistake here, and the parent ID needs to be an IPAM pool, so we actually have to create a separate pool first for this, which is fine. We can do that. We can do IPAM pool on-prem. The type is IPAM pool. Just for sake of time, we're gonna accept most defaults here. The body in the properties, required properties, is the address prefix. So here we'll put in this address prefix. Copy that. Paste this in here. Do I need to do anything else? We can do the display name on-prem network. And then here for our CIDR reservation, I guess we don't need the address prefix. We're just going to say that we want to allocate all of the addresses. And for security, we're just going to do schema validation enabled false and run a plan for this. Looks good. Let's run a apply. Oh, I forgot. It's good if I actually also then point to this resource. So let's do IPAM pool on-prem ID. Let's just run apply again straight away. So that was finally created successfully. So if we go back into our shared services where we have our network manager, we can actually see it right here. So we have our on-prem IPAM pool, and then we can see we have an allocation, and it's gonna look a little bit different. It looks like this. But this way we have it tracked both in Azure, but we also have it tracked in Terraform and in state, or not in state, in Git. And it's version controlled and it's documented in that manner. But guys, that's going to be it for this video actually. So we went over how IPAM works and how you can work with it using Terraform, and how you can reserve addresses that are not in Azure. Also how you can just dynamically grab the next available addresses that you want for your virtual networks. And I don't know, I like it a lot, but have you used it? So let me know how you got on with it, and if you have any questions you can leave them down below. If you liked the video, please like, maybe subscribe, and I will see you guys in the next one. So thank you very much, take care.